we're going to take a break from finding derivatives, and we're going to talk about logarithmic functions. So just like we talked about exponential functions, we're going to talk about logarithmic functions prior to finding derivatives. So let's get started. First, I'd like you to recall that the natural log of x is equal to b if and only if e to the b is equal to x. So the reason being is because natural log of x is the same thing as log base e of x. The natural log of x, ln of x, is equal to log base e of x. Because it's the natural logarithm, and we use it so often, the base e is not written. We just write ln, and that means that that logarithm has a base e. So when that logarithm has a base e, if I say that this is equal to b, then our base raised to the exponent equals our argument. Now another thing is if e to the b equals x, we can write this as the natural log of x equals b, and that's because we would have log base e of x equals the exponent b. And likewise, this if and only if means that I can start the opposite way and say if the natural log of x equals b, then e to the b equals x. So lots of different ways to say the same thing. We're going from exponential form. So this is our exponential form of a logarithm, and this is our logarithmic form of a logarithm. We're going to graph y equals the natural log of x. Y equals the natural log of x. This is a parent function, and I'm going to write here log base, and then we have our argument. Move this over a little bit, use some of my space, equals the exponent. So when we have y equals the natural log of x, my base is e. Log base e of x. So sometimes I write log base e of x just so that I can see that. That's my y value. It's my output. So remember that the argument has to be positive. Must be positive. And that's because your base is going to be positive but not equal to 1. So your base is going to be positive but not equal to 1. So if our argument is positive, that means it's going to be greater than 0. So a number, our base, is going to be some number raised to an exponent. That base is going to be a positive base raised to any exponent will always give me a positive output. So a base, a positive base raised to any exponent equals a positive argument. I think that's what I was going to say. Lost it for a minute there. So a positive base raised to any exponent will equal a positive argument. So it's very important for you to understand that. That's why our argument is a positive and our exponent can be any value, positive or negative. So we have the natural log of x x is going to be our domain. Our domain is going to be greater than 0. So it cannot include 0. It's going to be greater than 0. Our asymptote, if you'll recall, is going to be vertical, and it's going to be x equals 0. And you get that by set the argument equal to 0, and that will give you your asymptote. You get your domain by setting your argument greater than 0. So we have that vertical asymptote at x equals 0. If I were to put a 1 in for x, log base e of 1 is equal to what? Well, e to the 0 power is equal to 1. So when you put a 1 in to your natural log function, you'll get a 0 out. So 1 goes into the argument, and you get a 0 out. If I put a 2 in, I get a number that I'm not sure out. But if I put log base e of e in, which is 2.718, so if I go right 2.718, I'm going to get a 1 out. And then the next value that I can put in is 7.4-ish, and I'll get a 2 out. And then my graph of my natural logarithm is going to hug that vertical asymptote as the vertical asymptote goes down to negative infinity. So that's the graph of our natural logarithm. Now, if you were a little confused about that, remember that y equals the natural log of x is the inverse of y equals e to the x. So I'm going to graph y equals e to the x. So let me change this color because I want to do this in purple. So in purple, y equals e to the x, 0, 1, 1, 2.7-ish, 2, 7.4-ish. And it had a horizontal asymptote, and then you can see that these are symmetrical about the line y equals x, which makes them inverses of one another. So this is y equals x, and this is y equals e to the x. So y equals e to the x and y equals the natural log of x are inverses of one another. And that's how you graph them. So you could always graph the y equals e to the x and then reverse the inputs and outputs. So 0, 1 will become 1, 0. And 1, 2.7-ish becomes 2.7-ish, 1, and so on and so forth. Okay, now in the next video, we're going to work with our our logarithmic rules. So we're going to recall some of those rules that you learned in a previous course, but very, very important for you to know how to apply them when we start using them with calculus.